Alright, so we've made it all the way to the end of Chapter 2. Let's take a look at Section 2.8, Eliminating Fractions and Decimals. And this is on page 84 in your textbook. So first things first, let's do a little bit of an opener. We just want to review if we're distributing with fractions, what do we do here? So anytime we're multiplying with fractions, first of all, we'll have 5 times a. That's easy enough. And then the next one will be negative 5 over 1 times 3 over 5. Just for a quick review, that we know that our 5's cancel and we're left with 5a minus 3. This one we have a 3 over 1 times our 1 over 3x. So our 3's are canceling, our 1's cancel, we're just left with x plus 3 times 5 is 15. And for the last one we have 3 sets, so let me write each one out. So we have 6 over 1 times 1 over 3a, and there's a minus 6 over 1 times 2 thirds a plus 2 times 6, or it should be 6 times 2. So we can go ahead and work these out. So our 3 and our 6 cancel, this would become a 2 and a 1, so we're left with 2a minus our 6 and our 3 will cancel again. This time we'll have a 2 and a 1. 2 times 2 will be 4a plus 2 times 6 is 12. And then we finish up with 2 minus 4a would be negative 2a plus 12. Then the other thing we want to do to open up, to kind of warm ourselves up here, is to find least common multiples. So remember, those, whenever we are multiplying with 6 and we're multiplying with 15, what's the first number we would come to? That's like writing out the multiples for 6, so it'd be 6, 12, 18, 24, 30, 36, and then writing out for 15, so we'd have 15, 30, and we'd see there that that's our least common multiple is 30. And then for 8 and 28, we could do the same thing, writing out our multiples, and we would find that our least common multiple for 8 and 28 would be 56. So this section, our last section of Chapter 2, is on equations with fractions and eliminating those fractions whenever we're working with them. So to eliminate fractions from an algebraic equation, you can multiply both sides of the equation by the least common multiple of the denominators. So to do this, first step is to find the least common denominator, then eliminate fractions by multiplying both sides by that least common denominator, and solve the resulting equation. And then, of course, always, always, always check your solution. So example 1 says x over 4 plus x minus 1/3 equals 3. Now this is pretty messy, so we want to get rid of these fractions. So we want to say, all right, well, what does 4 and 3 have in common? Well, the least common denominator, or the least common multiple between 4 and 3, is 12. So we're going to multiply each by 12. So that means I'm going to multiply everything on this side of the equation by 12. And then I'm going to multiply this side of the equation by 12. So when it's going to be like I'm distributing a 12 to the x over 4, to the x, and to the negative 1/3. Each chunk needs to be multiplied by that 12. And then we'll have the 3 times the 12. Now I realize I just wrote out the same thing, but I want you to see what's happening. So we'll have 12 times x over 4. Well, those will cancel. We will end up with a 1 and a 3, so this will be 3x plus 12 times x, well, that'll just be 12x. And then 12 times a negative 1/3. So we'll have 12 times negative 1/3. Well, our 12 and our 3 cancel. This time we end up with a 4 and a 1. So 4 times 1 is 4. Remember, there's a negative sign here, so we have to bring it down to our bottom. And then 3 times 12 is 36. Combine our like terms. We have 15x minus 4 equals 36. Add 4 to both sides. We get 15x equals 40. And then divide by 15. We end up with x equals 40 over 15, which reduces to 8 over 3. And remember, having an improper fraction is perfectly acceptable when we're solving our algebraic equations. So x equals 8 over 3. All right, let's go ahead and take a look at example 2. So for example 2, we have a quantity of x plus 2 over 6 minus the quantity of x minus 1 over 3 equals 1/9. So first we need to go ahead and eliminate our denominators. So what is the least common denominator? Our least common denominator is 18. So we're going to multiply each side of our equation by 18. And it'll look like something like this for each step. So it'll be 18 times x plus 2 over 6 minus 18 times x minus 1 over 3 equals 18 times 1 over 9. And then here we can start eliminating our denominators. So our 18 and our 6 cancel. We have a 1 and a 3. So we have 3 times what's left in the numerator. So 3 times the quantity of x plus 2 minus, again, we cancel. So we'll have 6 times the quantity of x minus 1 equals, those cancel, and we'll have 2 times 1. Then we can go ahead and distribute and combine our like terms and then finish solving. So we'll have 3x plus 6 minus 6x plus 6, so we have a negative 6 times a negative 1, equals 2. Combine our like terms. So our 3x and our negative 6x will have negative 3x, positive 6, and a positive 6 will be plus 12, equals 2. And then just finish solving. So we have subtract 10 from each side. Or, no, sorry, subtract 12 from each side. And we'll get a negative 10. Negative 3x equals negative 10. And then divide by negative 3 on each side. We end up with x equals, our negatives cancel out, so we end up with x equals 10 over 3. For example 3, they're giving us a word problem. So it says the coach has developed a drill that requires a rectangular field with the width being 1/3 of the length. The perimeter of the field is 280 feet. What length and width should the field liner mark off? So first of all, we know that the width of the field is 1/3 of the length. So since we're referring everything back to length, we're going to set length as our variable. So let x be the length of the field. And then we said the width is 1/3 of the length. So 1/3 x will be the width of the field. And it also told us the perimeter of the field is 280 feet. So we know that perimeter equals 2 times the length plus 2 times the width, or 2 L's, L plus L plus W plus W. So we could also say that since we said our length was equal to x and our width was equal to 1/3 x, we could say it's x plus 1/3 x plus 1/3 x equals, and they gave us this 280 for the total perimeter. So let's go ahead and solve this. So we want to get rid of our denominators. Luckily, it's just a 3, so our common denominator is 3. So we're going to multiply everything on the left by 3, everything, which is just that one quantity, by 3 on the right. So we'll have 3 times x plus 3 times x plus 3 times 1/3. Well, our 3's will cancel. We'll just be left with 1x. Again, our 3's will cancel here, so we'll just be left with 1x equals 280 times 3, which is 840. Now we can combine our like terms. We have 3x, and another 3x, that's 6x, plus x gives us 8x equals 840. And then when we divide each side by 8, we get x equals 105. So that's the first part of our question. The first part said what will the length and what together says the length and the width. So we said the length is going to be x, so the length is 105 feet. And then we have to figure out, well, what's the width? Well, we said the width was 1/3 x, or 1/3 of the length, which is 105. So 1/3 times 105, which will give us 35 feet. So we have a length of 105 feet and a width of 35 feet. So that takes care of solving equations that had fractions. Let's look at solving equations that contain decimals. So in these equations, you can multiply both sides of the equation by a power of 10. Remember, powers of 10 look like 10, 100, 1,000, and so on. So let's take a look at example 4 in your book. Example 4 says solve 2.6x plus 12.24 equals 0.27 times a quantity of x minus 6. Now this is going to be pretty messy to work with because of all of our decimals. So we're going to go ahead and get rid of them. The way to get rid of decimals is to see what is your longest decimal value. How many places does it have? So we have one with 1 decimal, and then we have some 2 decimal places. So we're going to go with the 2 decimal places. So to eliminate 2 decimal places, we're going to multiply by 100. 2 zeros, 2 decimal places, that's going to take care of it. So we're going to multiply each side of our equation by 100. So this side will look like 100 times 2.6x plus 100 times 12.24 equals 100 times 0.27 times quantity of x minus 6. Now, when we multiply this side, we are only multiplying this front value. We do not multiply inside of this second set of parentheses. So don't worry about multiplying this by 100, just the outside value. So we have 100 times 2.6. We're just moving that decimal 2 places, so we end up with 260 x plus 1,224 equals 27 times the quantity of x minus 6. Then we'll go ahead and distribute. So 27 times x will be 27x minus 27 times 6 is 162. And everything on this side gets to stay the same for this step. Then we can go ahead and move our x's to the same side. Subtract 27x, subtract 27x, which leaves us with 233x plus 1,224 equals negative 162. We will subtract 1,224 from each side. we're left with 233x equals negative 1,386. Hold on, I lost my pen. There it is. Negative 1,386. And then we'll just go up here to finish it out since I ran out of room. So it'll be 233x divided by 233 and negative 1,386 divided by 233. And we will get x equals, or x is approximately, negative 5.95. And in this case, we rounded to the nearest hundredth because we started out with hundreds places. So if you're ever wondering, where should I round to? They'll either tell you or do what the original problem started out with. So the original problem started out with the biggest place being hundredths, so we should round to the hundredths place in our final answer. And then last but not least, when we're talking about decimals, a really great example of working with decimals is coins. So real quick, we just need to talk about coins for a second. These are things we already know, but sometimes we forget when we start to plug in information into problems. And that is working with the actual value of each coin. So pennies are worth 1 cent, nickels 5 cents, dimes 10 cents, and quarters 25 cents. These are things, of course, we know, but just to review. And then to give a number assignment, we could say pennies are worth P, or nickels would be N, D for dimes, quarters. So this is their value, that's how much they're worth. This is the how many of each. So when we have our number, it's how many of each. So how many pennies are there? And we would take the value of 1 times the number, the unknown number of each, and that would equal our total value of each. So this would be our total value of each. This was our value for 1, and this is our total value for our pennies, our nickels, our dimes, or our quarters. So when you're solving coin problems, read. Find the main unknown and assign a variable to it. Then express any other unknowns in terms of it. So what coin do they refer back to? What coin do they refer back to? And that is the coin that you are going to assign a variable for. Next, plan and organize by making a table indicating the number and the total value of each type of coin. So total value, that's your key. Make sure you're assigning a value to your coins. Solve an equation obtained by using the information in the value column and any other information from the problem. So remember, we had our value for 1, we had our variables for our number of coins, and then we had our total value. And we said our value for 1 times the number of coins equals our total value. So we'll want to use a similar type of chart to set up our information, and then use that information, this times this equals that, to solve an equation. And then of course, always check your work. So let's take a look at this last example. So our last example says Chris has 17 coins, all dimes and quarters. So first of all, just to begin with, we know that we're working with 2 different kinds of coins. We are working with dimes and we're working with quarters. So we have, what kinds of coins do we have? We have dimes and we have quarters. Then it says he has a total of $2.45. How many of each coin does he have? So we're going to have our number, we have the coins we know we're working with. We're going to have a number of coins. And we have our value of coins. So this is our chart. And then we have our totals. So we know we have a total number of coins that's going to be 17. And we have a total value of $2.45 when all is said and done. So, how many of each do we have? Does it say there's 2 times as many quarters or 5 times as many dimes? No. It just says there's quarters and dimes. So we're just going to have to pick which one do we want to have our variable for. In this example, they're assigning a variable to the quarters. So if we have something plus x equals 17, the opposite of that would be 17 minus x equals this. So 17 minus x is our dimes. Separate that off there. 17 minus x is our dimes. Our quarters is x, and then that 17 minus x, or the difference, plus x will equal 17. Then we need to talk about our values. Well, how much is a dime worth? A dime is worth 10 cents. A quarter is worth 25 cents. And our total value of coins is going to be this times that. So it'll be 0.10 times 17 minus x, and 0.25 times x. And these things added together will equal $2.45. So that's where we get our equation from. So we end up with 0.25x, or they used q, I believe, in the book, but that's okay, plus 0.10 times 17 minus x. We could put them in the same order I wrote them out as. I'm just writing the equation in the same order that they wrote it in the book. And then we say equals $2.45 total. Now we're ready to solve. First things first, let's get rid of these decimals. So how many decimal places do we have? Well, our biggest decimal place is 2, so we're going to multiply each side by 100 because 100 has 2 zeros, so it's going to eliminate those decimals for us. So we'll have 100 times our 0.25x plus 100 times our 0.10 times the quantity of 17 minus x. Remember, we are only multiplying that front number, not the number inside of our parentheses. And then equals 100 times 2.45. So we'll end up with 25x plus 10 times the quantity of 17 minus x equals 245. We can go ahead and distribute. So 25x stays the same. We'll have 170 minus 10x equals 245. We can combine our like terms. We have 25x and a negative 10x. We'll have 15x plus 170 equals 245. I know I'm going through this kind of fast. Remember, you can always pause or back up the video if you need to copy this down, or if you just want to try it on your own and see what you end up getting. So next step, we're down to a 2-step equation now, so we'll just subtract 170 from each side. We end up with 15x equals 75. We can divide each side by 15 to get our x all by itself, and we end up with x equals 5. So we have x equals 5, but does that actually answer our question? Our question says how many of each coin does he have? So no, not quite yet. That means how many quarters does he have? Well, quarters would be our x value, so quarters are 5. How many dimes? Well, 17 minus 5 equals 12. So we have 5 quarters, 12 dimes, and then we should always check our answer. So 12 dimes would be $1.20. 5 quarters would be $1.25. When we add those up, we get $2.45, which checks out. We got the correct answer. So, looks like we have just one more example. I'm out of white pages, so let's just back up here. We'll clear this one out, and we'll do our last example. This is example 6 in your book. So example 6 says a coin bank contains 4 more quarters than nickels, twice as many dimes as nickels, and 5 more than 3 times as many pennies as nickels. If the bank contains 22.25, how many of each coin are in it? So again, we'll go through this kind of fast. Feel free to pause at any time. So let's just lay out our chart first. So we have quarters, dimes, nickels, which I always spell wrong, and pennies. Now, everything in our word problem refers back to nickels. So nickels is what we're going to choose to use our variable for. So we have nickels. Then we have 4 more quarters than nickels. So 4 more would be plus 4, nickels plus 4. Twice as many dimes as nickels would be twice as many dimes as nickels, so 2n is our dimes, and 5 more than 3 times as many for our pennies. So now we have our number of coins for each, so now we need to come up with our total value. Well, a quarter is worth 0.25, so we'll have 0.25 times n plus 4. A dime is worth 0.10, so we'll end up with 0.10 times 2n. A nickel is 0.05, and then a penny is 0.01 times our 3n plus 5. And we said all together they have $22.25. So this is the information we will use to set up our equation. So we have 0.25 n plus 4 plus 0.10 times 2n, 0.05 n plus 0.01 times 3n plus 5 equals 22.25. Just enough room. So I would really like you to try this one. Go ahead and distribute, and then eliminate your decimals, and then combine your like terms, and then check back and see how you're doing. Okay, so go ahead and check what you did. The first thing I did was I multiplied by 100 to get rid of my decimal places. Then I distributed, I combined my like terms, and I ended up with 53n plus 105 equals 2,225. Now I'm down to my two-step equation, so I can go ahead and solve. I'm going to subtract 105 from each side. I'm left with 53n equals 2,120. I'm going to divide by 53 on each side, and I get n equals 40. Now, once I found n equals 40, I'm almost done, but I have one more thing I have to do, and that is go back and say, now, how many of each did I have? Well, for quarters, I had n plus 4, which is 40 plus 4. So for quarters, I have 44. Then for dimes, it was 2n, or 2 times 40, so I will have 80 dimes. For nickels, well, we already answered nickels. Nickels were just n, so that is 40 nickels. And then pennies were 3, n plus 5, or 3 times 40, plus 5, 3 times 40 is 120, plus 5 more is 125. So these are my final answers. Last thing to do would just be to go back and check. I promise you they do actually check out. We do end up with $22.25, so we are good. So I really like these problems. I hope you get to like them too. They do take a little bit of work to try to figure out where you're going with them, but once you have the hang of it, I think they're really fun. So I hope you enjoyed this lesson. Go ahead, take a look at your assignment, and finish out Chapter 2. Let me know if you have any questions.